are done with the first page, and now we are going to go on to the second page. So the second page has 6 different steps to be labeled. I want you to note that these steps are not the complete and entire picture of the sliding filament theory. We have additional room within these steps where you need to take good notes. I will be highlighting the different things that you want to note, but really pay close attention and take good notes, because after this, you are going to be pairing up into partners and you are going to be explaining the sliding filament theory from your worksheets to your partners. If you need additional paper, I would hope you have some notebook paper, but if not, we do have some paper in the back of the class. You can just raise your hand and I can get some for you. Make sure you take good notes, pay close attention, and I will be highlighting the different steps and also the other things that you need to note. So this is the process of the sliding filament theory. So in blank number 1, write down nerve impulse arrives. This is the first step. We can see in our picture, we have this nerve and there's this little zappy thing, and that represents the nerve impulse arriving. Once the nerve impulse arrives, we have step 2. Acetylcholine is released. Acetylcholine is important because the presence of acetylcholine causes the depolarization of the motor end plate. Now what this does is it allows calcium to be released from the sarcoplasmic reticulum. So step 3 is calcium is released from the sarcoplasmic reticulum. I will spell out sarcoplasmic reticulum in case you need the spelling of that. That is SARCOPLASMIC. That sarcoplasmic reticulum is RETICULUM. Sarcoplasmic reticulum. So let's go over steps 1 through 3. Step number 1, the nerve impulse arrives. Step number 2 is the release of acetylcholine. And step number 3 is the release of calcium ions from the sarcoplasmic reticulum. Now, what happens when calcium is released from the sarcoplasmic reticulum? Well, now the myosin filaments change their shape. And this is important because when the myosin filaments change their shape, they are now able to bind to the actin. So these are the myosin filaments. You can see the little myosin heads and the actin. Once the myosin filaments have changed their shape, they are now able to bind to the actin. So step 4 is a cross bridge is formed. Once the myosin head is bound to the actin, a cross bridge is formed. Step number 4, cross bridge is formed. Once a cross bridge is formed, we get to the actual contracting part, and that is step number 5. We want to note that number 1, energy is released. Where are we getting this energy from? We are getting this energy from ATP. ATP is converting the energy and is releasing the energy. And once energy is released, the myosin is activated. Now, once the myosin is activated, it does this contracting motion, which pulls the myosin head and the actin filament to the left. So it's going backwards. And this is the actual contraction. So step number 5, we have energy is released, myosin is activated. Myosin, the spelling of that is MYOSIN, and muscle contraction occurs. Step number 5 is where the actual muscle contraction occurs, because once again, ATP energy is released. The myosin head is able to contract, and the muscle pulls. Step number 6. Step number 6 involves, after the muscle contraction occurs, we saw in the video and we heard in the video that this muscle contraction can continue as long as there is enough ATP energy and enough calcium. But once that is used up, then the ATP is attached to the myosin head and the cross bridge is broken. So step number 6 is the cross bridge is broken. ATP connects to the myosin head and the cross bridge is broken, because ATP energy is what helps connect it to the actin, and the actual ATP is what helps break the cross bridge. Once that is done, we have calcium that is pumped back into the sarcoplasmic reticulum, and the actin and the myosin head return back to their resting positions. Now, for this process to go back and start all over again, what needs to happen is another nerve impulse. And once another nerve impulse comes in, then acetylcholine is released. And once acetylcholine is released, then calcium is released. And once we have calcium released, the myosin head changes its shape and we have a cross bridge that is formed. Once this cross bridge is formed, we now see the release of energy. Make sure that you take note that it's energy and not ATP. The release of energy from the ATP is released, the myosin head is activated, and it is able to attach and contract. And once the contraction occurs and there is enough ATP and calcium, it'll continue to occur. Once that is used up, then ATP, not ATP energy, actual ATP will connect to the myosin head. And then that breaks the cross bridge. And we do the whole process all over again. Do we have any questions? All right, perfect. So now we are going to split up into pairs. I'm going to split each of you up individually, and you are going to use your worksheets and your notes to explain to one another this process of the sliding filament theory. I'm going to give you about 3 minutes per person. If you have any questions or you want some clarification, I am available, but go ahead and split up and explain the process.